being there in ISRO. That's I am doing for the last few years. So here for today's talk, all of you are aware that why are we celebrating a week, right? Anybody is not aware, please raise your hand. Why KSTA is celebrating 1 week science fair? Not aware, you say. I am not aware, sir. You will get gift if you say I am not aware. One of you should say, I don't know why KSTA is celebrating 1 week science fair. All of you are aware? No. If you say so many no, I cannot give gift to all. Only I can say give it to one person. You can come, madam. I can give it to you, this gift. The girl said, I don't know. Because if you say that I don't, the black t-shirt, if you say that I don't know why we are celebrating, I am very happy to inform you the purpose of this particular meet which Dr. K.M. Ramesh is organizing. I would like to tell you that February 28th, what is it? National Science Day, right? Why is it being celebrated? There is little confusion among scientists also that on that day itself, Dr. C.V. Raman, in fact, Professor C.V. Raman has invented the Raman effect is being told, but it is not so because that is a confusion there. On that day, he delivered his famous discovery, a famous talk in Central College in Bangalore University. That's a special attachment to the Bangaloreans you have, right? Because of that, to commemorate this particular thing, it is being celebrated. Every year we are celebrating, no sir, what is so special this year? This year is so special because we are at 75th Amruta Mahotsava. Because of that, we are putting lot of efforts. If you ask Ramesh, he will explain the kind of difficulties he is undergoing to organize such a huge fair here. Because it's nowhere arranged, only 3 places, Bangalore, Mysore. Of course, your colleges they will arranging. This kind of a festival is very, very important where you get an opportunity to learn. So with this few introduction, let me go to the topic which is given to me. See, normally there is a theme for the Amrut Mahotsav is any important milestones which are called 75 milestones. You have to communicate to the general public as well as the scientific minds what are the important milestones, 75 milestones. That is the title given. As a part of that morning you have heard IISc Professor M.N. Murthy's. He has explained you about the many engineering colleges, the growth of engineering colleges, IITs, IIMs, ISRs, NITs, right, IIITs, right. He was also mentioning about ISRO, but let's look at in detail about ISRO. So the topic which has been given to me by Dr. A.M. Ramesh is Milestones of Science and Technology in India. I have taken a case study of ISRO. Hope you are not familiar with ISRO, like that I will assume. Is it correct? Are you familiar with ISRO? Who are all familiar? All of us are familiar. Please raise your hand, I am not familiar. Only one hand I want. Please come forward. I am happy if you say I don't know, because that's the reason that we are here and you are here to learn this one. So, another problem with you? Okay, that's right. Now, before I get into my actual topic, because you are all maybe first semester or first year engineering, right, or graduation degree. You have an objective in your life. Why do I choose to study and what do I study? All these 3 will be your answers. Because I want to make a good career. Forget about I am studying electronics, mechanical, all those things. Okay. So that is the definition of a career. And what do you want to do in career? You want to achieve something which I am now trying to struggle to make some achievement, because after my career I have entered studies, I am struggling in my organization to do some good achievement so that others will praise. That is your second achievement. After achieving, like here professor is there or M.N. Murthy has come, they are striving towards excellency. You understand the meaning of excellency, right? Your principal is there, but still he will be struggling to prove that he is an excellent in managing, right? So these are the 3 important objectives for us when we choose any subject or any study. Let's little bit go front. What are all the choices available? Yeah, what are all the choices available for you? Okay. If you look at it, I can do undergraduate. You are all undergraduate students? BE, BTech, right? Anybody BCom? Anybody is there BSc? BBA? Yes. So you have undergraduate program. Immediately after the undergraduate program, you may go for job. Is it right? You will go for job, right? Some people will aspire for the higher studies. What do you call as PG, MBA, MSc, MCom, BTech means MTech, right? So that's your motive. What for? To know, to do some kind of a service. Either it could be a technical or it could be a non-technical. Sometimes it is humanities also. After that also, some students will go for higher study in research. Like if you ask Professor Gangadharaya here, when he was a student, he aspired to become a researcher, right? So he is a motivation to many of you here. If you listen to him in his classes, lectures, he is motivating many students. So that's the area where maybe few of you may go for a research, all may not go. So this is kind of a pyramid structure in our education system. So afterwards, what you will see benefit wise, after graduation, whether I am getting good salary or not. If I am getting good salary, I can buy a house, car, all those things, you will settle down, right? That's the kind of one set of people. Some people even after BE will not be satisfied, they will go for higher studies, even if a job is there. There also again this question will come, whether I am satisfied. That's the reason I am giving you the previous one, excellency. If you are not satisfied, you will work towards excellency. You want to improve yourself. So same way in PhD also, there are so many research scientists, they have done enough in physics, but they will migrate to chemistry. Can anybody give the example of that particular person who has got the Nobel Prize? He worked in one domain, he is achieved or not achieved, satisfied or not satisfied is different, but he moved to the other domain, but he got a Nobel Prize in that one. He belongs to India. Because we are celebrating this fair because of the Nobel Prize got to C.V. Raman. He also hails from the same family. Anybody know name? Anybody know the name of a person who got Nobel Prize recently? You should be knowing. Any one name? Okay, keychain will be with me. Afterwards, I will give you Venkatakrishnan. Venki they call it as. Please browse it when you are seeing it. He studied, I think, DNA. He got the Nobel Prize in DNA. So that's the reason here also, because study never ends. Why I am covering these 2-3 slides before I get into my topic, it is very, very relevant because being a student, you have to choose that way. Okay. Then what are all the career opportunities? Where do I get it? Nowadays, abroad opportunities are more. Because of this COVID, some restrictions are there. Otherwise, see, have you heard, how many of you heard Ambedkar went to do his law or MA or PhD in non-technical nonsense, correct? Have you recently heard any graduate going for a BA? MA? What is it happening then? If you ask me, Rahul Gandhi studied in London. If you ask me, Adani's son studied. A common man, why they are not going for doing BA, MA nowadays? We are studying here only, right? But when during the independence time, struggle time, even though graduation, post-graduations were there were a scholarship. You read the autobiography of Ambedkar, he got a scholarship to study in London, study in USA, right? He did 2 PhDs. Just imagine what is it happening in our education system. The new education policy is bringing new changes. You can study about that. My point is not that. There are opportunities for BA, BBA, BCom equally as much as an engineer. That's the point which I am trying to say. But we are not exploring. Recently, I recommended one student who did BSc in Bangalore. He said, I will not join any universities in India for MSc. I want to go Europe only, like that. He wasted 1 year, but he is now studying MSc in quantum physics. I mean, it's your desire, it's your choice to make your career. That's the point I'm trying to bring here. Then there are so many, other than these two, what you can do. If you have seen the inaugural session, many MLAs were there, many people were there, social, helping social organization. This is how you can also contribute to the country, these things. I will come to my actual talk. I think this I have covered. It's going forward, okay, sorry. Yeah. Now, with that little bit introduction, why do I am linking to ISRO? Because I want to draw some people to my organization. What are all required? If one of you, like BA, BCom, whatever the discipline, there is a scope, there is a possibility of serving our country. You want to go abroad, please go. But you want to serve my country, you choose your destination as this one. So ISRO has a vision to harness space technology for the national development while pursuing space research and planetary exploration. You may be, some of you may be BCom, sir, mujhe kya kaam milega idhar, I don't work, sir, I am a BCom student. Don't think like that. We have BCom studied people also working in various other capacities. So what is its mission? We have to design and develop launch vehicles. Slowly I will show you what are all those things. We have to design the satellites for different applications like Earth observation, communication, navigation and meteorology. Also we have, all of you are familiar with GPS, right? I will explain slowly. GPS kind of a satellites we have to build it, that's there. Then in remote sensing also a lot of applications we have to do. Then space based application for society development like teleeducation, telemedicine, that I will show you. Then research and development for space science. You have heard Chandrayaan 1, Chandrayaan 2, similar thing. That's the purpose. You can refer more here. ISRO, please try to browse the ISRO. How did ISRO start? This is the first step. It happened in Bangalore again. Please remember, this is the first balloon experiment done by Homi Bhabha. If you read the history, Homi Bhabha brought Vikram Sarabhai. I will tell you who is he. So this is the first experiment done in Bangalore. In fact, I should have asked a question and given a keychain. This has happened in Bangalore. First balloon experiment happened here to study the atmosphere. So that's how they felt that Bangalore is suited for doing some scientific research. Now, Homi Bhabha I introduced you. The other person is Dr. Vikram Sarabhai. I will show you his photograph. Yeah, he is Vikram Sarabhai. Just keep in your mind. Can anyone say from which state he belongs? I will come back to my slide. You will get a keychain. So what he did, Vikram Sarabhai, he is called as a father of Indian space program. He studied with C.V. Raman. That's the reason linked to the Science Day, National Science Day. C.V. Raman advised him, you go to London to get your PhD. When he was there in London and later he moved to America, Homi Bhabha met him. What are you doing here? Why don't you come back to India? India got freedom. I am doing lot of activities there, lot of atomic energy related developments I am going to do there. Why don't you come there? But he was presenting in COSPAR, Committee on Space Research for Peaceful Applications in the United Nations. So then he said, yes, I have a dream for my country. I will come back. I will work and I want to make my own space industry. So Vikram Sarabhai and Bhabha jointly surveyed India. This is the place they first identified. It is called Tumba. It's a small village in Kerala where they found it is suitable for doing. Earlier I have shown you the balloon experiments, right? Better than Bangalore. This place is better. And he proposed this place to the United Nations, or in principle America those days. They offered Apache Nike rockets. You can see somewhere here. You know, when I say Nike, you will say only shoe. Correct? No, it's not so. You study more about it. Nike Apache rockets were given. They are small sounding rockets, they say. The word sound means you have to disturb the atmosphere. When rocket goes up, it disturbs the atmosphere and payload will be dropped to measure the temperature, pressure, humidity, such kind of a things. That's the first experiment they did it. These are all the dates, you can read it. Such rockets are called Rohini Rockets, which are now currently indigenously. I will tell you the story. At this point of time, India didn't have any rockets. It was just given by the Americans. Okay, lot of stories you can read. I will narrate certain different stories. With that as a seed process for India to become, now we are 6th topmost power in the space nations. Okay, except sending humans to space, we are equally good with America. That's the kind of a standard. So where all ISRO is there. This is the overall organization. These are all spread out here. We directly work with the Prime Minister. Space Commission will be there. This is a recently reform made in space, and it's called Department of Space. Then you have various scientific organizations. I will brief you slowly. These institutions I will show you so that you get familiar one by one. And this is another what you call as our private corporations to do a lot of business with the external agencies. These are all our ISRO centers. This is the center where I belong, ISTRSA. I will give you the one by one the brief of this organization. It is spread across India. Now even now we are trying to do more new centers as well. Yeah, come back to Vikram Sarabhai. What was his interest is he wanted to make India as a spacefaring nation. In principle, if you read his autobiography, in the beginning he has put his pocket money to make rockets and satellites. At that time, of course, Nehru supported him. At later stages, he found difficult to run the space agency. Government said we will not be supporting. He didn't discouraged. He continued. He found Professor U.R. Rao, whom you are seeing here. He made him as the head for the satellites. He found Dr. Kalam, who made him to work on rockets. You are all familiar, right? PSLV. So he was the principal architect. So that's the kind of a power he had to mobilize the talent across India. The satellite making company was started in Peenya, where I am working. Then the rockets were made Tumba, I told you, no, Tumba, which is a small sleepy town in Trivandrum, near Trivandrum. That's the power he had. At the very early age, he left us. That's a very sad for us. Otherwise, we would have even seen more development. If you see him, he is a very rich person. This is another lesson we have to learn from. He is a very, very rich, golden spoon you can say it, because the Sarabhais and Sarabhais are very big industrialists in Gujarat. But he has a strong desire or interest in science. So he wanted to make more scientific organizations. Huge number of institutes he has built. National Institute of Design, any of you have heard? It is made by him. NID Ahmedabad, NID Bangalore, it is there. Okay, lot of textile industries are there. In spite of that, he wanted to develop the government agencies which can serve for the country. That's the kind of people we have dedicated to serve the country. That's the lesson we have to learn for our future. Now, so this is a small story. When they visited this particular place in Tumba, it's a church. Remember, again, another message is there here. So it's a very busy church. This was only stone, study, rocky building available in this particular village called Tumba. All are our Guduslu, we say hut. All are hut, fishing hamlet. Okay, there is no other building available. But this great man wanted a laboratory there. Bring rockets from America, put there, integrate, tie it. He wants a place. Then he straight away walked into the church padri or a father. He requested him, I am so and so, I have this kind of a plan. Can you give this church to me? Can you imagine, can you go and ask KST and Anakbekul on the Angdi Itkotini? I mean, it's not so simple. So the way he went and approached the person, the father straight away said, yes sir, I am handing over the entire church to you. Even today, this church is a big museum, very big museum. Lot of rockets were made in those days. That's the kind of the national integrity we enjoy in India. Whether it is whatever may be the religious place, when it comes to the scientific temper, scientific development, we are ready to sacrifice anything. That's the sacrifice which the church father has made. Today, it stands a big milestone in the history of space science. Lot of rockets are made here. So that's a big story. Please read it. So entire credit goes to Dr. Vikram Sarabhai. Currently, who are all there? Where are we? Who are all contributed to the ISRO? See, this was the first chairman, Dr. Vikram Sarabhai, then Professor M.G.K. Menon, he is from Mangalore. Those who are from Mangalore here, you can study about him. Professor Satish Dhawan, recently you heard IAC professor lecture, right? I think M.N. Murthy was also worked with him. He was IAC chairman, very dynamic leader. In his name, there is a center in ISRO called Satish Dhawan. Then Professor U.R. Rao, you have seen here. He has also contributed a lot, Udupi Ramachandra Rao. Then Dr. K. Kasturarangan, exceptional, successful chairman of ISRO. Professor Madhavan Nair, a launch dynamo we called, very dynamic leader. Then Radha Krishna, who is very well known for the Mars Orbiter mission. Then you have Dr. A.S. Kiran Kumar, who is from Asan, who has also contributed extensively on satellite payload manufacturing. Recently, Dr. K. Shivan, who is famous for Chandrayaan launch, you have seen him. He just retired. Now currently Dr. Somnath, very young, dynamic, talented leader, very inspiring leader for all of us. He is heading us. So this is the story, how to follow them. Now let's come back to the different organizations. What do we make? I told you in the beginning, we make rockets, satellites, and launch them, operate them, maintain them for the life of the satellite. And whatever data, whatever the products or whatever the services, you have to give it to the societal development, right? So one by one, which institute is doing what? It will be helpful, because if you are studying BE Mechanical, where do I get a job, sir? If you are studying only BCom, where do I get a job? I am studying some BSc, sir, where do I get a job? If I am an MTech fellow, this will help you. So Vikram Sarabhai Space Center is in Trivandrum. Their main job is towards the manufacturing of rockets. Okay. Then Liquid Propulsion System Center, it's in Valimala and as well as in Bengaluru, where the whatever you need for rocket fuels, especially liquid fuels, they manufacture here. So I am just giving you a little brief of the center and the photograph. This is the place, it's called Satish Dhawan Space Center. It's a Sriharikota, SHR, Sriharikota High Altitude Range, which is there in Nellore district of Andhra Pradesh. This is U.R. Rao Satellite Center, named after Professor U.R. Rao, which is there in Old Airport Road. Okay, many of you might have seen or not, please do visit. It is possible they will allow the students also on certain occasion. There is a museum. Being in Bangalore, you should see it. NAL, HAL, then you have that. So where major satellite is manufactured. From here only satellite will be shipped to Sriharikota for launch. From Trivandrum, rockets will come to Sriharikota. Okay. Now this is again a propulsion related center which is there in Mahendragiri, where they manufacture, test the engines, because you cannot test engine in an open area or a city. You need a big forest or a big mountain where the heavy sonic sound, which should not disturb the civilization. This is a good place where you can do a lot of rocket testing. They do it there. Then you have a space application center where payloads are, cameras are manufactured. Cameras are manufactured and it will be fitted in satellite. It is in Ahmedabad. Okay. Now this is as I said, from satellite whatever data comes. All of you are familiar with Google Maps, right? I will be showing Indian map similar to that. Okay, which will be prepared data processing from the satellite. All will be done at NRSC Hyderabad. Anybody is there from Hyderabad? So this is NRSC, National Remote Sensing Center. Then this is a center where I am working. What we do? We receive telemetry, tracking, command data. We maintain the satellite's health. We maintain satellite until its life of the mission. We maintain low Earth orbiting satellites around 1000 kilometer height, and we also maintain planetary satellites like Chandrayaan 1, Chandrayaan 2 and Astrosat. That's our job here, which is there in again Bangalore, Peenya. Hopefully if you get a time, we will take you there. Some occasions we will invite the students, or if you are aspiring for a job, these are all the centers where you have a job opportunities. Generally every year 2 times we will take the job opportunities. This is another ISRO inertial system unit which is there in Trivandrum. Here like navigation related things, when satellite is moving up or rocket is moving up, it has to be controlled. You need inertial systems, that is manufactured there. Mechanical engineers, they get lot of job. This is another center in Bangalore, laboratory for electro-optics, where I am wearing specs, right? So it is called as a lens. So for camera you need a lens, big lens they will manufacture there. When I am looking at the stars, I should understand the pattern of the star and navigate myself. Like same way satellite, when it is revolving around the earth, it should look at the stars, moon, sun and decide its position. It's called as a navigating sensors. So these are all manufactured in Bangalore, which is called the Laboratory for Electro-Optic Systems. Then another institute where a lot of training will be given for students. You can actually register during the lockdown time. So many courses they started. How to use satellite maps. How to use satellite maps for your daily applications. They give training here. It's called IRS Dehradun. Then this is in Hassan. Anybody is there from Hassan? It's called Master Control Facility, where geostationary satellite. When I say geostationary, all TV and communication satellites are maintained there. Launching will be done by them. Maintenance means daily they have to talk to the satellites through telemetry, telecommanding, see their health, see their operational services are continued. Okay, this is a general brief. What is ISRO? Where all ISRO centers are there? What we have done? What are the milestones which ISRO has achieved? All of you may be familiar. Maybe a little more information I would like to try to add. What are all the launch vehicles available? Right now these two are not operational. Gslv is operational. All of you are aware, right? You have seen outside it is there. Geosynchronous satellite, geostationary satellite launching vehicle, polar satellite launch vehicle. In the Gslv we have higher versions where we have ambition of sending humans to space using human rated Gslv. This is a major milestone of ISRO is building self-reliant rockets. Okay, you don't have to go ask either China or America, please launch it. Whereas even now there are so many big countries like Brazil and Pakistan, many other countries, they don't have their own rockets. We have our own rockets. We are self-reliant. That's the kind of a pride you associate with ISRO. Now second one is, what is the use of satellites now? You are saying, sir, satellite, where is it being used? You are all familiar with Google Maps, right? Even Google Maps also takes our own satellite pictures. Like there are various applications where you can see how much land is being cultivated, how much land is being wasted, how much land is land cover, land use. That's the kind of a terminology they use. If you join after BSc or MSc for remote sensing courses. They will teach you all those things. Then you can also study about the agricultural. Every monsoon, before monsoon, entire India, how much land is plowed, how much land is ready for agriculture, crop estimations, that kind of studies you can do physically going there, but it takes more time. But in a single strip, in a single image shot, entire India photograph will be coming. They will, agricultural people, they will estimate this is coconut, this is paddy, this is some other crop, mango plantation. So you, every year they have to do it audit for a better policy decision. Then ocean applications, what is happening? There is a good story on ocean. They are helping fishermen to go to the exact location of fishing, potential fishing zones. That is done by the certain ocean site application. Then soil study, soil moisture study. Then you have other what you call cartographic application. If you see the story of Bangalore International Airport, I can show you in map. If you go back 20 years back, there was nothing there. All of you have seen the Bangalore International Airport. Now you have a beautiful airport, right? So how did they choose that location? What maps might have helped? If you want to build a new airport, or if you want to make urban development, you cannot go take a camera and either you can go drone or by airplanes. But I want the previous year's map also to study that one to make a decision whether it is suitable for any such mass what you call infrastructure, mass building, very huge buildings. Satellite data will help you to make a decision on urban development. Okay, there are so many applications. In same way, you have communication satellites. So many are there. 50 plus satellites are there in India. See, always be proud that the highest is by America, Russia, China. Then we are also there. 50 plus satellites we have. When we say that it is like an asset to the country, like we say in our home, asset is there. No, same way, if you have a satellite, you are a self-reliant. These are the communication satellites. If you are seeing a TV, below that satellite name will come when you switch on sometime. Which satellite, which frequency all will come. So a lot of communication applications are there. Banking sector, tele-education. Nowadays, COVID time, you are all doing online classes, right? If you have seen, VTU has taken one big program, EduSat program. They used to, see, suppose one big professor is there in VTU Belgaum, but you want to listen to his talk. Now you have internet, but it was first demonstrated by ISRO to make available that lecturer through satellite to the all college classrooms. That's called as a tele-education. And the people at Port Blair and remote places, if they suffer some serious health issues, they want to consult Bangalore doctor, Devi Shetty. Devi Shetty cannot be travelled there, but over satellite they did that experiment. It was successfully demonstrated. Now you see so many such services have come in private players. Tata 1mg, online phone call, video, audio, WhatsApp videos are there. But it was first demonstrated by satellite based telemedicine, tele-education. Okay. Then for disaster, even now every half an hour to 1 hour, India image will come, where you can see the movement of cyclone, how it is moving. Generally during monsoon time, we have a severe cyclones in India. You have to periodically monitor it and estimate the kind of a damage it can do, where it is going to collapse on land. So that is successfully managed last 5-10 years. We are minimize the damage caused by the cyclones. That's because of the satellites which are there in geostationary orbit. This is a new concept, not very new, but all of you are familiar with GPS, right? GPS service provided by whom? Yaro? Which country? One keychain. Who is providing the GPS services? US. Yaru helidri? Toli. Yaro bro. Who comes forward, he will get it. Okay. Do mila to dusran ko de do. So, now, what is GPS doing for you? I have a mobile. This mobile satellite connect agidya. GPS bartirbeku. When you are getting a GPS, how does GPS works? Anybody has thought? How many satellites are there GPS? 32 plus satellites are there. At any one point of time, 3 satellites minimum are visible. It will not talk to me because this is not satellite phone. You have to have another satellite phone. Okay, but whereas this is talking to mobile tower. Just mobile tower illadre GPS also service will not be available. SIM card if it is not there, it will not be available. Whereas all towers alli satellite connectivity nu irutte. GPS receivers hakirtare. Because of that, you can get the GPS. We are getting only civilian service. Whereas GPS has 2 types of service called military service as well as civilian service. Civilian service is I want to know my position, I want to go to one location, give me the path. That is application built in. But who is giving latitude, longitude and time is by the satellite. When you say GPS, or in general word it is called navigation. You have GPS by America, GLONASS by Russia, BIDU by China, right? India's is NAVIC. We call it as navigation. These are all navigation techniques. I want to go from one place to other place. On land it is easy. On sea, your mobile tower is not there. You have to use the satellite technology. So here this GPS is supported. Like similar way, ISRO has built in our own self-reliant constellation of satellites where NAVIC services started. I think there is one Realme X650 model. Some model is there. They have started for the first time NAVIC services. When you are buying a mobile phone, you will look for the specification. There GPS compatibility like that it will be there. Same way now they are writing GLONASS compatibility, BIDU compatibility, okay, like that it will be there. Now we are getting very soon in market NAVIC based mobiles where you can use them for specific navigation applications. Lot of applications are there. Airports are already operationalized. They are using the satellite signals for their navigation applications. Now the major milestones of ISRO is Chandrayaan 1. Now 2 also is done. We are working on Chandrayaan 3. This is regarding the Chandrayaan 1. What is the greatness of this mission? Anybody knows? Anybody has read anywhere? Yes? What is that? Yes, water formation. For you one keychain, sir. It will be here, you can take. Okay. So what he is telling is, see what happened, from 69 onwards, America is busy working on moon. All of you have heard Yuri Gagarin name, right? He is a man landed on the moon. 69 to 2003, just maybe 50 years approximately you take that way. Okay. What is the overall outcome of American study on moon is a dry subject. When I say dry subject, not like your subject boring, literally meaning dry. That means what? There is no water. That was the overall chapter conclusion on a study of the moon. But at that time, 2003, we started the moon missions. In fact, they laughed at it. There was a cartoon saying that गाय को पकड़ के इस space club के अंदर घूम रहा है India वाला. Such kind of cartoons have come. They have ridiculed us. Even though NASA is working with us, see any interplanetary mission or a big missions we cannot do alone. They will also be working with us because you have to go around. So that time there were certain ridiculing attitudes saying that India kya karega, what India can do. But it's not so. This mission along with the NASA, they also work with us. They have what you call certified, or they have said the inventions are correct. Water was detected for the first time. Even now any lunar chapter is written, when water story comes on the moon surface, they have to write Chandrayaan 1 name. It was detected by Chandrayaan 1 mission. That's the kind of a greatness which we have contributed to the global science. Okay. So there are detailed things we can study later. I am just giving you a little brief, a major milestone in the history. Chandrayaan 2, of course, we could not do much successful story on this particular lander, but still even yesterday we have released one particular observation by solar flare which is impacting the moon. There are the pure science interested people. They will be, yesterday there is an announcement in ISRO website, you can see the Chandrayaan 2 has detected solar flares on the moon surface. Of course, it's an interesting mission. Lot of PhDs are being made by the students. Huge science data. We are only hosting in my center. Only we are hosting the data to the general public as well as scientific community. That's the story of Chandrayaan 1. Then Mars mission. Anybody know what is the speciality of this mission? One major. Yes, for you one more here. I will leave it here. You please take. Why first attempt so important? Sir? Yeah, that's all difficulties. Always we have a comparative mind, right? America ने 50 बार किया, उसमें 50% only successful. So that's where even America has acknowledged the success of this story, because space is always risky. Even though you're 100% correct in your engineering science, chances of failures you cannot avoid. It's not zero. So everybody thought, actually one more cartoon was released this time, Mars time, it will not be a successful. China has said it will not be a successful. But this was the most successful mission, first attempt, which has captured the Mars orbit. Okay. Currently it is working, 7 years continuously it is working. Data it is getting released. We are receiving data. There is a place, I will show you the photograph at the end, near anybody from Rajarajeshwari College or Mysore Road, RV College, From there another 10-15 kilometer if you go, big banyan tree is there. Have you gone? Dodalad Mara. Please do visit my place also. Next another 5 kilometer. That is my workplace actually. It's called as Indian Deep Space Network. We track Moon, Mars, other missions. 125 acres campus it is there. Very big campus. We track all planetary missions. So this is being tracked from there. It is live. Good. It was planned 6 months. It is working more than 6 years. That's the kind of a success our own people are doing. Here you don't need any big, even to say that a normal engineer, we are all working together to make a big success. You don't have to be a NASA scientist. Many students will ask me, sir, bade hoke main NASA mein jana chahta hu. Good, please go, no issue. But being here also you can make an impact in the domain of science. Sorry. Now these three are the missions which I would like to show the actual photograph of satellite, how it looks. If you have not seen it, it's a rare opportunity because even being in ISRO we cannot enter to that laboratory. So this is how it looks. This is Astrosat mission. Now the future is for you, in fact me and you, we have to work towards making India successful in this mission. That's the target which government has given to us. What is Gaganyaan? Sending humans to space, recovering them safely, successfully. Okay. Currently, America has mastered this technology. Of course, Chandrayaan itself, like Yuri Gagarin, all those things. Russia is good at it. Now Japan is good. Recently, if you have seen during lockdown, China has sent 2 times 3 people. Right now 3 people are revolving around. Chinese 3 people are 1 girl, 2 boy. I should say woman astronaut, men astronaut. Okay. Same way, International Space Station, 7 people are revolving around. Totally 10 people are in space. Have you heard anywhere? Have you studied? 319 days. Last 319 days. For no keychain now. You have to say yes, you will get keychain. Okay. So 10 people are revolving. Now our ambition in coming years is an Indian boy or a girl should revolve around the earth, come back safely. That's we are working towards that. Hopefully we will be seeing another year or 2 first launch, second launch, both will be unmanned, third will be a manned one. Once you get the confidence, we will send the astronauts. Okay, that's the story of ISRO. But you will say, sir, that's a government job, I may not get, what should I do? But still I want to work in space domain. NAL, HAL, aerospace, Boeing, all are there. But in ISRO itself, what are the private opportunities? This is a recent development which is happening in ISRO is, there are certain private companies we are encouraging. They have given few lists, there are so many, more than 30 companies are there. The best companies I have listed here. Agnikul, please Google it, zoom it, browse it, find out what are the job opportunities for you. Agnikul, Bellatrix, Pixel, Skyroot. If you have not heard it also, please, Zovian, ARDL of IASC, Team Indus, Exceed Space, Dhruva Space, Earth to Orbit, Astrom, Kava Space, satellites. These are research institutes of ISRO where you can go for a further higher studies. Now private players are also joining with us because it is the overall nation taking forward in the domain of space. So you have to involve private and government both to be involved. That's the message in this slide which I would like to tell. I think my time idya idre tondre illa. I will take for a questions. This is the place I told you, big antenna dish is there, 32-meter antenna we say it, where we can communicate Pluto beyond Pluto. Okay, that's the power we have. See, earlier we were only capable of communicating, any communication engineers, he will understand the difficulty of communication, up to 1000 kilometer. 36,000 kilometer we were able to communicate because of the Hassan center, where geostationary satellites will be controlled and monitored. Now my center where I am saying, we can go moon 4 lakh kilometer, Mars 200 to 400 million kilometer, beyond Mars, Venus also tested, it can go beyond 1.5 million kilometer, which is called as a Lagrangian point. So these are all being tested. This is the milestones which country has achieved, how far you can send Indian signals, right? Whereas NASA has sent beyond Pluto, Voyager 1, anybody heard? Please go out of our solar system, it has gone out, it is still sending signals. 30 years back launched, it is still sending signals. So we are also in the same domain, we can send up to Pluto beyond using this one. At this point I will stop. If you have any questions and interactions we can have. Okay. Any questions are there? Or if you have not understood, you will get keychain. I have a video I can play for the last hour. A video ಹಾಕ್ಬೋದು. ಇಲ್ಲ open ಇದೆ ನೋಡಿ. Play the video, they will see it. If you don't have a question, please watch the video. If you have not understood, please tell me. I will try to answer.
ಅರ್ಥ ಆಗಿಲ್ಲ ಅಂತ ಹೇಳ್ರೋ ಕೀಚೇನ್ ಸಿಗುತ್ತೆ.
ಅಷ್ಟು ಜನಕ್ಕೆ ಕೊಡಕ್ಕೆ ನನ್ನ ಜಾಬ್ ಚಿಕ್ಕದಿದೆ. I brought only 5-6. Good. ಅದು ಪ್ಲೇ ಆಗಿಲ್ಲ.
Sir, could you turn off the switches there at the back? Yeah. Thank you.
ತೆಗಿಲ್ಲ.
ಸರ್ ಯಾರು ನಿಮ್ಗೆ ಹೇಳಿಕೊಟ್ಟಿದ್ರೆ ಇಷ್ಟೊತ್ತಿಗೆ ಗೌರ್ಮೆಂಟ್ ಸಿಗ್ತದೆ ಏನಾದ್ರು ಒಂದು ಕಡೆ ಇರ್ತಿದ್ವಿ.
ಹೆಲ್ಪ್ ಆಗಿದ್ರೆ ಸಾಕು.
Space age, which launched a 1,000 more campaigns to space and beyond. To many, the horizon now became the new frontier. In India too, the idea of space was born in the cradle of space program, the physical research laboratory under the leadership of Dr. Vikram Sarabhai. It was born when the country was battling against poverty, unemployment, low productivity, food deficits, and poor infrastructure facilities. To combat this scenario, Dr. Sarabhai ventured into realizing the dream of using satellites for education and development of the country. To achieve this, the concept of the Indian National Satellite System was floated, and the Indian National Committee for Space Research, INCOSPAR, was constituted in 1962 to supervise the phased implementation of the INSAT system. In order to achieve an end-to-end satellite system, Dr. Sarabhai knew it was imperative to also develop satellite launching technology. So, the first project of ISRO was setting up the Thumba rocket launching station, TERS. Due to absence of a ready building, Dr. Sarabhai could convince a small community to allow church building to be used as the facility hub. The Indian space odysseys began when the first sounding rocket, Nike Apache, was launched from this facility to study the upper atmosphere. Space Science and Technology Center, SSTC, was established at Velli near Thumba for developing technology for rockets and satellites. India's first indigenous sounding rocket, Rohini 75, was launched on 20th November 1967 from Thumba. The first experimental satellite communication Earth station, ESCES, was set up as a training center for the Indian as well as international scientists and engineers. It was 1969 when the Indian Space Research Organization, ISRO, was formed. With a clear mandate of spreading development and education through satellite, India's first communication satellite system launched the TV program Krishi Darshan, a program that helped the farmers with information to increase the crop yield. To prove the efficacy of a satellite system in disseminating educational and developmental television programs for the rural population, ISRO initiated the ambitious Satellite Instructional Television Experiment, SITE, in 1975, covering 2,400 remote villages of India. SITE then became the biggest ever techno-societal experiment in the world. Taking learnings from SITE a step ahead, ISRO worked on Kheda Village Communication Project in 1984, which proved to be a space-based development communication laboratory. Then came the time country waited for. The first Indian spacecraft, Aryabhatta, was developed by a young team at ISRO, which gave the Indian space program all the wings and vigor it really needed. ISRO thereafter continued to progress in using the space technology for its advancement. ISRO started defining India's first experimental geostationary communications satellite, Apple. The first generation INSAT was successfully launched in 1982, coinciding with the Asian Games. Between 1992 and 1999, ISRO developed the second generation INSAT satellites with a combination of C, extension C, KU and S-band transponders. ISRO also launched meteorological geostationary satellite Kalpana-1 in 2002, which was later followed on by INSAT 3D and 3DR, the world-class series of communication satellite. Over the years, ISRO has successfully passed the experimental phase, development phase, and operational services, and has now successfully established communication, meteorology, remote sensing, space and deep space science, and the navigation satellites. Establishing operational satellite-based system for the nation is one of the key achievements of Indian space research. EduSat, Chandrayaan-1, India's first mission to Moon. Mars Orbiter Mission, India's first interplanetary mission. Astrosat, India's first space observatory mission. Indigenous navigation constellation. High throughput satellite. Third generation Cartosat satellites are some of the complex and challenging missions realized by ISRO. On the other hand, the satellite mass has considerably increased from 37 kilograms Rohini satellite to 6-ton class GSAT-11 satellite. Onboard power varying from 40 watts to approximately 15 to 20 kilowatts. Data rates up to Gbps. Improved control and pointing accuracy and mission life from a few months to 15 to 20 years. While during the experimental phase, the philosophy followed a conservative engineering. But today, the operation of satellite is based on a single model philosophy based on a bus concept. The on-orbit operational flexibility has also grown from a few on-off commands to time-tagged and group command to perform complex maneuvers and to have spacecraft autonomy. As far as the heart of the satellites, the payloads are concerned. Newer payloads are now developed to meet the mission objectives with optimization with respect to performance and onboard resources. Payload design has undergone technological upgradation in various parameters like resolution, coverage, altitude, spectrum, signal strength, data rate, mass, size, power, etc. ISRO trusts in collaborative efforts. It has been engaging industries in realization of subsystems, fabrication, assembly and testing activities. Currently, around 75 small, medium and major private players, PSUs, are supporting ISRO in satellite realization activity. All the technologies mark their success if the end use is for good. Tele-education and telemedicine are two flagship societal applications started by ISRO to bridge the digital divide in the society in education and health sectors to the remotest and secluded parts of the country. Many other applications are today supported through these communication satellites. Direct-to-home TV is most visible. Through this, TV has truly entered the home of a common man. In the 70s, ISRO also had the responsibility to develop the remote sensing program. It was started rather modestly by Professor P.R. Pishardi when he laid the foundation of Indian remote sensing with the now famous coconut wilt disease experiment, which was carried out using Soviet aircraft and American color infrared camera. The lessons learned from the experiment bore fruits in form of the Bhaskara satellites 1 and 2, which had TV camera with 1 kilometer resolution and microwave radiometers Samir. Simultaneously, ISRO worked in all the 3 segments of space, ground and applications. The National Natural Resources Management System was established to steer the remote sensing applications in the country, and broad domains of applications were developed along with the user agencies. As an outcome to this activity, IRS-1A, 1B and 1C were launched. IRS-1C was the best civilian remote sensing satellite with close to 5-meter resolution. It employed a unique 3-tier imaging system and the push broom scanning technique to produce world-class imageries. Subsequently, this approach was adopted by many other countries. To enable longer operations, new ground stations were established across continents to enable other countries acquire IRS data. The IRS series paved the way for the thematic series of satellites to improve applications in the area of land use, cartography, oceanography, and climate. Over the years, ISRO has perfected the art of developing various types of sensors in visible, shortwave infrared, and visible near-infrared regions. India today is the proud custodian of the world's largest constellation of remote sensing satellites. The system offers the space-based Earth observation data in variety of spectral bands, spatial resolutions and swaths providing data on crop production estimation, potential fishing zones, urban planning, disaster management and many other applications. A state-of-the-art ground station facility to receive data from high-resolution satellites along with data processing and storage facility have been installed at Shadnagar, Hyderabad. ISRO today has strong and rich Earth observation data collected over some 40 years. The Bhuvan portal of ISRO is a popular web-based portal that serves its users' needs 24/7. A sophisticated decision support center, DSC, serves as single window delivery mechanism for monitoring, mapping and dissemination of information on all natural disasters to the coordinating authorities. Be it town planning, disaster management or the early warnings for disasters, ISRO today has made its impact in all. Traveling back in time, while work was on for satellite development, progress was also vigorously made to develop launch vehicle technology and the launching facility. ISRO zeroed on to Sriharikota Island as it was found suitable for geosynchronous and the polar satellite missions. This location was operationalized in October 1971 as a spaceport for Indian space programs. It is today regarded as one among the best locations for launching space missions. A major milestone in the journey of Indian space program was achieved in 1980 with the first successful flight of indigenous launch vehicle SLV-3, having a capability to place 40 kilogram payload into the low Earth orbit. With this success, competence was built up for overall vehicle design, materials, fabrication, propulsion, power, avionics, vehicle integration, and launch operations. Development of Vikram Sarabhai, Vikas liquid fuel engine, was successfully developed by ISRO in the 1988. Since then, it is a vital component of all launch vehicles. The first successful flight of Augmented Satellite Launch Vehicle, ASLV, paved the way for learning the nuances of launch vehicle design for complex missions. This path led to realization of workhorse, ever-reliable launch vehicle, the Polar Satellite Launch Vehicle, PSLV, in 1994. Over the years, PSLV has also undergone many technological upgradations. It is available in core alone, 6 strap-on and XL versions. It is a versatile launch vehicle for variety of polar and geosynchronous missions. It has also proven its capability for launching multiple satellites in a single mission. Its capability of engine restart of the upper stage has further enabled it to launch satellites in different orbits in the same mission. In XL version, PSLV can launch a payload mass of 1.75 tons to low Earth orbit. PSLV was also instrumental in launching landmark missions like Chandrayaan 1, the Mars Orbiter mission, and has also created world record of launching 104 satellites in one mission. It has also launched 342 foreign satellites of 34 countries. To achieve self-reliance for launching satellites to geostationary orbit, propelled ISRO to develop heavier Gslv Mark II and Mark III vehicles. Starting in 2001, first few flights of the larger Gslv rocket were equipped with Russian cryogenic stage. As a result of focused efforts, ISRO succeeded developing C-12 cryogenic upper stage, and the first successful flight of Gslv Mark II with indigenous cryogenic stage took place in January 2014, when Gslv D5 launched GSAT-14 satellite. Gslv is now an operational vehicle capable of launching 2-ton class of satellites into geostationary transfer orbit. The heavy lift Gslv Mark III, capable of placing about 4-ton class satellite in GTO, had its first experimental suborbital flight in December 2014, when it carried a 3,735 kilogram care module to a height of 126 kilometers. The module later safely landed over Andaman Sea and was successfully recovered. Gslv Mark III D1, the first development flight of Gslv Mark III with indigenous C-25 cryogenic upper stage, took place in June 2017. The vehicle launched 3,136 kilograms GSAT-19 spacecraft successfully to GTO. In November 2018, in its second developmental flight, Gslv Mark III successfully launched GSAT-29 satellite and is now an operational launch vehicle of ISRO. Through this journey of progress, ISRO always kept the words of Dr. Sarabhai at realm, which meant once we find ourselves comfortable in dealing with our own societal issues, we can experiment with the space technology to explore the beyond frontiers for the betterment of humanity. 13 years ago, ISRO successfully launched Chandrayaan 1 in 2008. This was India's first mission outside Earth's atmosphere, and thus began ISRO's new epoch of science missions. Chandrayaan 1 had 11 payloads built in India, USA, UK, Germany, Sweden, and Bulgaria. It discovered the lunar hydration and the enhanced abundance towards the polar region, and indicated possible presence of water molecules along with other molecular species in the lunar environment. Chandrayaan 1 deposited the Indian national flag on lunar surface when its moon impact probe landed on it. Mars Orbiter mission was launched in 2013 and has completed 7 years around the Mars. It has 5 science payloads, all built in India. The mission has produced global albedo map of Mars. The data sets were also used for the study of surface, atmosphere, pole, and moon of Mars, Phobos and Deimos. Astrosat was launched in 2015 and has completed 6 years in orbit. Astrosat has 5 science payloads, all built in India. It is India's first astronomical venture to study the universe in several wavelengths simultaneously from a single platform. It observed a gamma ray burst and also detected extreme UV light from a galaxy called AUDFS 01, 9.3 billion light years away from Earth. It observed a galaxy cluster Able 2256 containing 100 to 1000 galaxies, which is one of the most massive gravitationally bound structures in the universe. Chandrayaan 2 was launched in 2019 and the orbiter has a total of 8 payloads, all built in India. It has completed 2 years around the moon and is providing extensive information about the minerals and water. It has been able to distinguish between hydroxyl and water molecules unambiguously. The data from Chandrayaan 1, Mars Orbiter Mission, Astrosat and Chandrayaan 2 can be accessed from Indian Space Science Data Center, Bengaluru, which is available for scientific and outreach purposes. It is now next to impossible to lose your way in modern times, thanks to satellite navigation, as it can pinpoint your location to within few feet, wherever you happen to be on Earth, just in no time. The Indian Regional Navigation Satellite System, now called the Navigation with Indian Constellation or NAVIC, provides the users of Indian subcontinent within the radius of 1,500 kilometers with accurate position expected to be better than 20 meters and timing accuracy expected to be better than 40 nanoseconds on a 24/7 all-weather basis. Like any other satellite navigation system, NAVIC 2 has 3 parts to it: the space segment, the ground segment, and the users segment. Space segment of NAVIC consists of a network of 7 satellites with atomic clocks along with their downlink signals. This network works as sky landmarks just like the landmarks we have on Earth, as their positions are fixed or known to us. The ground segment comprises of the IRNSS Spacecraft Control Facility, IRSCF, which maintains the NAVIC satellite constellation, and the ISRO Navigation Center, INC, and its associated facilities that facilitate position, navigation, and timing data broadcast by the satellites. The users segment consists of a receiving device that one carries. The combination of 3 will help in getting the information regarding the precise location of a person on Earth or a moving object on Earth or atmosphere. All ISRO networks like MCF, ISTRAC, SHAR now use NAVIC timing receivers for network time synchronization, satellite launch and tracking operations. 5 national power grid sites are now installed with NAVIC receivers for power grid control, measurements and monitoring applications. The day isn't too far off when the entire nation will switch over to NAVIC, making India truly Atmanirbhar. In the 75th year of India's independence, ISRO is steadily progressing with the Gaganyaan project. It is conceived to take Indians up above the world, where they will stay up to 5 days, perform experiments and then come back on Earth safely. India will be the 4th country to orbit Earth with humans after Russia, America and China. The preparation for this mission began in 2007 when ISRO successfully conducted the Space Capsule Recovery Experiment. This was followed by CARE mission in 2014. Again in 2018, a pad abort test was conducted for demonstrating human crew escape system in case of an exigency. LVM-3 10 CARE mission was launched to demonstrate the technologies of the crew module at suborbital level. It is planned to initially send 2 crewless missions for technology demonstration, safety and reliability verification, and to study the performance of various systems. In the actual manned mission, during the return journey, the capsule carrying the astronauts will land in Arabian Sea or Bay of Bengal. Aditya L1, the first Indian mission to study the sun, is meant to observe the solar corona and outer layers of the sun. It will be launched in the third quarter of 2022 using the Polar Satellite Launch Vehicle PSLV in XL configuration. The satellite will be placed in the halo orbit around the Lagrange point 1, L1, which is 1.5 million kilometers from the Earth. Lagrange point is where the gravitational pull of Earth and the Sun on the satellite is equal to the centripetal force. This creates a point of equilibrium needed to keep the satellite in orbit. We can say that the spacecraft is parked at this point so as to make observations. The Winged Reusable Launch Vehicle Technology Demonstrator, RLVTD, is a space plane which will act as a flying test bed for overall mission management of a winged re-entry aerospace vehicle. This technological marvel called RLVTD will open new frontiers and avenues for low-cost access to space using fully reusable Indian space transportation systems. ISRO has successfully launched 112 spacecraft missions and successfully executed 82 launch missions. This has translated into people having hundreds of 24/7 TV channels or talk to their loved ones at a touch of a button, or being rescued from a disaster, to knowing the total crop yield of the nation. ISRO is working on 30 approved satellite projects in communication, Earth observation, navigation, and space science missions. It is committed to harnessing space technology for national development while pursuing space science research and planetary exploration. India's space odyssey is resolute, steady, and determined. It shall continue to explore the unexplored, be compassionate for the newer technologies and vistas, all for the sustainable development of our societies. This reminds us of those golden words of Dr. Vikram Sarabhai, which he had inscribed on a school board some 55 years back.
In my opinion, the aspect of space research which I would like to stress most is in relation to the national capability, the self-confidence that this will generate. And if I were to give my own evaluation of this, I think the benefits of these far outweigh all the rest that we have been talking about.
Somebody sitting at the back, could you turn on the switch, please? Is a request.
I hope it was a useful lecture. If anybody wants to ask, say that I have not understood, this is not good, any feedback of your feelings, please express it so that we can have a better program next time. If you have not heard the story of ISRO, we believe that we have done some little effort to make you understand what is happening in the country.